Welcome to IGS Seeing the Finish Line, a senior design project by Janae Butler, Andrew Kuick, and Matt Rupnick. Our sponsor was Dave Spar, and our mentor was Eric McDonald. Who is IGS? IGS Industries is a custom parts manufacturing company that began in Pittsburgh in 1961. The parts they manufacture include, but are not limited to, gaskets, shims, industrial sealants, rings, and other metallic and non-metallic parts, and service many industries. The IGS facility has multiple manufacturing departments. For our project, we took a closer look at the finishing department and its processes. The finishing department is made of 7 machines and stations and run by a small team of cross-trained workers.
IGS is currently experiencing a disorganized process flow in the finishing department, prohibiting the department from maximizing its full potential. The department lacks visibility of incoming orders, thus it is unaware of what orders need processing that day, what machines the orders will require for processing, and how long the orders will take at each machine or station. IGS employees are currently making these decisions by manually determining how to prioritize the order, what processes the order needs to move to next, and when that movement occurs. As a result, the company experiences high work in progress, continuous flooding, and inaccurate processing times.
We decided on 4 objectives that would allow us to improve IGS's finishing department. 1. Provide the finishing department with visibility. 2. Create standard practices at each of the workstations. 3. Update the job sheets, which are the paper routers that travel with the order. 4. And create a new layout for the finishing department.
In order to accomplish our objectives, we decided to approach them using the following 7 steps.
Before diving into our results, it is important to lay out some of our interesting findings and results. For starters, the heavy press department that comes before the finishing department runs 2 shifts in a day. The finishing department only runs 1 shift every day, resulting in them always having 1 day worth of work in progress. Also, we discovered that there are 20 process flows that an order can possibly go through. There are several limitations as to what process step can and cannot precede each other. Lastly, the hand sand station and vibe room are constrained to current location as they could not feasibly be moved.
We were able to come up with implementations and solutions to satisfy each of our mentioned objectives. 1. In order to provide visibility for the department, we advise implementing a moving rack system. This system will require the work in progress to build on the racks before entering into the department. Orders will be placed on the racks, which will be prioritized by due date. Once the rack for the closest due date is pulled and distributed inside the department, the following racks behind it will replace the preceding rack. This system will be accompanied by visual work instructions. Not only does the system allow for workers to view their daily workloads and better prepare for the day, it also keeps the department organized by building work in progress prior to entering in. 2. After the orders are distributed, we decided to move all of the orders to the station based on a first-in, first-out prioritization method. A FIFO method will force the stations to follow a standardized process and keep the process flow going in one direction. 3. Our next implementation, in the form of a physical deliverable, is the Excel macro sheet created to update the job sheets. This sheet serves 2 main purposes. The macro allows the user to input order information and, in return, get back the finishing department process steps in their respective order. This allows for the workers to not rely on their knowledge or learning curve to make processing decisions, but on the standards of the order specifications and requirements. Another function of the macro is that it uses information from our time study to calculate order processing times. Thus, it will record how long it should take to process an order through the finishing department. 4. Lastly, we created a new layout of the finishing department that will promote a better process flow. The notable changes are the movement of all of the machines to the bottom half of the department and the table stations to the left side of the department. This was done in order to keep the counting and packaging stations, which never have an order go to more than one of them, separate from the stations where multi-processing options are possible.
After completing our time studies in the project, we modeled a simulation based off of our objectives and compared it to IGS's current system. As a result, we recognized 2 important things. IGS's current information that they input into their system is inaccurate and underestimates a job's processing time. The graph shown displays the difference in time between our processing times and theirs for a small sample of orders. We calculated a 301-minute difference in processing times, which resulted in a 7% difference in throughput. IGS quotes their services based off of their processing times, which means that the company is underpricing its services and should be charging more and turning larger profits. The other important finding from this simulation is that using the moving racking system discussed previously results in an 80% decrease in work in progress across the entire finishing department. It is our hope that IGS uses our suggestions to improve their process flow. Within the next couple of months, each of our objectives should be implemented into their system.
In the long term, we hope that IGS can take advantage of their scheduling module in the ERP system to provide visibility of incoming orders. We entered the relevant stations into their ERP system along with their capacities. The next step is to pick a date to start running off of the schedule and to coordinate with the heavy press department.
We would like to thank IGS Industries for their time and continued cooperation throughout this project. A special thanks goes to Eric McDonald with Catalyst Connections for his guidance throughout the project. Lastly, we want to thank Dr. Lancasorn, Dr. Bedanda, and the rest of the IE faculty for their guidance and advice. Thank you for helping us not only see, but cross the finish line.